Hi, my name is Gina Porter. I'm the math specialist here at Rock Prairie Elementary, and we are going to talk for a few minutes about what's happening during the second 9 weeks in first grade math. Here's an overview of the second 9 weeks. They're going to start off talking about whole number relationships. Then they're going to start looking at addition and subtraction situations and using concrete materials, actual objects, to help model and solve them. And they're going to do some measurement of length and time. So right now we're going to talk about the addition and subtraction strategies that kids are going to use in first grade. Kind of as a background about this, we want to discuss the fact that we need to let students choose the strategy that works best for him or her. We can force a student to use the strategy that makes sense to us as an adult and as a mathematician who's had lots of experience. But that's probably not the best thing for their development. We need to let them use the strategy that works best for him or her at the moment, and then we provide opportunities for them to learn and use more advanced strategies as they're working through addition and subtraction, learning about it. And so some students are going to need to count from 1. If you say add 3 plus 2, they're going to need to count out 3 items. 1, 2, 3. They're going to need to count out a set of 2. 1, 2. And then they're going to go back and count all the items together. 1, 2, 3, 4, 5. Some students do need to do that. It seems redundant to us. They're counting from 1 3 different times, but that's where they start. And so a lot of the students are still at that stage. And so we need to let them do that. And you may be saying, well, how are we ever going to get them past that? The way we do that is to have conversations and to model our thinking and show how I'm thinking about this task and how I solve it. And that way they hear a different strategy. They kind of start relating it to what they're doing, and eventually they start moving forwards. Some kids are going to count from 1, but they're only going to do it once. Maybe they put out a set of 3, they put out a set of 2, and then they can just count 1, 2, 3, 4, 5. And again, if that's the stage they're at, we're going to let them solve it that way. And then we can say, and here's how I thought about it, and model your thinking and show them how you solved it. Some students are ready to start counting on from a number other than 1. So if I say to add 3 plus 2, they're going to be able to say 3, 4, 5. They can count on from the 3. They can conserve the number 3. Realize that there are 3 items in this first set, and I don't have to count them. I can just say 3 and then count the other set. Some students are going to start using the relationship between numbers to add and subtract, and we'll talk about that some more later. But again, we can model our thinking and show them how we would solve the problem. Do a think aloud, which means I'm just talking out loud about what goes on in my brain when I am solving this problem. And if we can force a student to use a strategy, we can say, hold the big number in your head and say this. And we can force them to do that, but that does not deepen their understanding. If we have the conversation and let them progress through the different stages, let them progress through the different strategies from less sophisticated to more sophisticated as they understand them, then that's really better understanding. It's deeper understanding. It is understanding that allows them to build on what they know and to learn more. Just forcing them to do a procedure a lot of times is very short term, and it is not something that they're able to sustain and build on. So we just need to keep that conversation going, asking them to explain their thinking and explaining our thinking to them. Some strategies they might use as the year progresses is to add 8 plus 7, and they're going to add through 10, because 10 is a very easy, friendly number to use. So I know that if I have 8 and I get 2 more, then that would get me to 10. And again, 10 is a friendly, easy number. So I'm going to take my 7 and I'm going to split it into 2 and 5 so I can get that 2 I need. Then I put the 2 with the 8 and I have 10. Then I'm going to take the 10 and the 5 that was left over from where I split that 7 and put the 5 with the 10, and that gives me 15. So I'm adding through 10. And so that's what's really important for students to learn all the different combinations that make 10. And in addition, in this one, they need to know combinations that make 7, that I could split 7 apart into 2 and 5. So learning all those combinations will help them do this kind of addition, and when we get into multi-digit addition next year in 2nd grade. They might also use doubles plus or minus 1. So with 8 plus 7, I know that 8 plus 8 is 16, because for a lot of people, just memorizing the doubles comes very easily. So I added an extra 1 to the 7 so that it would be 8, and I got 16. But now I need to take that extra 1 away. So I take 1 away from 16, and that gets me to 15. So my answer is 15. I could add 9 plus 3 using known fact, which is really the same thing we were doing with doubles. We knew our doubles and we used them, but we can know other facts too. For instance, if they just happen to know that 9 plus 2 is 11, well, 3 is 1 more than 2. So my answer has to be 1 more than 11, and 1 more than 11 is 12. I could also take my known addition facts and use them to help me with my subtraction. 12 minus 6 equals something. And I know that 6 plus 6 gets me to 12. So then I can turn that around and say, well, if I have 12 and I take away 6, then what's left is another 6. So in all of these, we're using what we already know to figure out something new. And that's where real learning happens. When we can take something that we already know and connect it to something we don't know in a new situation, that's where our brain is growing. It is physically building a connection in your brain. And that's where when real learning happens, when we make those connections. We would need to solve addition and subtraction problems where the unknown is in any position. 6 plus 4 equals something. 6 plus something equals 10. Something plus 4 equals 10. 10 minus 6 equals something. 10 minus something equals 4. Something minus 6 equals 4. So I took that fact family, and if I know the relationship between 6 and 4 and 10, I can solve any of these problems. We can model fact families. We can model numbers that have a relationship with each other using a part-whole model. This top bar that goes the whole way across, that's where I put the number that represents the whole. Down here, I have bars that go part of the way across. And these are the parts that I put together to make the 10, to make the whole. Later on, we might have more than 2 parts to make a whole. But for now, we've got these 2 parts that go together to make 10. And using this part-whole model, we can come up with all of these different situations. I know that something plus 4 is 10. I know that 4 plus something equals 10. I know 10 minus something is 4. And I know 10 minus 4 is something. So we can use our knowledge of fact families, and we can put it into this part-whole model to see it visually. And here's another part-whole model, and here the 4 is the missing part. Here's another example. So we know that we want them to solve addition and subtraction situations where the unknown is in any position. And sometimes that unknown is where we have an expression on each side of the equal sign. So students need to recognize that the equal sign does not mean answer goes here. They're very used to seeing 6 plus 4 equals blank. And they think that when they get to the equal sign, there should be a blank there, and they should write in the answer. And so we have to help them understand that the equal sign just means that what's on each side of the equal sign has an equal value. And I could write 6 plus 4 equals 10, but I could also turn it around and say 10 equals 6 plus 4. That it doesn't have to be in a certain order as long as the value on each side is the same. And again, they could have an expression on each side of the equal sign. They could have 8 plus something equals 6 plus 6. Well, I know 6 plus 6 is 12. So whatever goes here has to go with 8 so that I have 12. And so I know that 4 has to go here because 8 plus 4 gives me 12, and 6 plus 6 equals 12. They could do that with subtraction. an addition on this side. 5 plus 3 has a value of 8, so whatever I put with this 10 has to give me a value of 8. Thanks for watching. Again, I'm Gina Porter, the math specialist here at Rock Prairie, and if you have any questions about this topic or anything else, you are welcome to contact me via email, jporter@csisd.org, or you can call Rock Prairie and ask for me, and I would be glad to talk to you. We are going to have another Math for Parents session to talk about what's coming up in the third 9 weeks on January 5th in 2017. So I hope that you can make that session and keep learning about how you can help your child in math. Thanks for watching.